our question is to given a matrix chain A1, A2, A3, A4 till An. So I am given n matrices which are of compatible size for multiplication, that is each ai has size pi minus 1 cross pi, so that rows and columns of each neighbors match. So find the best way to parenthesize the set of matrices so that they can be multiplied, which requires minimum number of multiplications. So let's understand the question first. So given, let's say, 5 matrices, so we can parenthesize them like A1, A2, then A3, A4, A5 we can multiply together. Inside also I can now have, so I can have A1 in one parenthesis, then A2, A3, A4, A5. So let's see now, A1, then I have A2, A3, A4, A5. So I can parenthesize this itself recursively, so I can have A2, A3, A4, A5 together, then I can have A1, A2, A3 together multiplied, and then A4, A5 together multiplied, and now their product getting multiplied, or A1, A2, then A3, A4 multiplied first and then A5. So we have a lot of options we see, and what we see is that number of parenthesization is exponential. Basically we can have lot of options of multiplying. But one thing we also see that a lot of these calculations are repeated. Okay, so like we will see it further, but let's first understand some of the basic concepts of matrix multiplication. So if two matrices A and B are of size P into Q and Q into R, then they can be multiplied because the column of first matrix is equal to the row of the second matrix. So we get C is equal to AB and its size will be P into R, and each element Cij will be given by summation k is equal to 1 to Q Aik into Bkj. So we see here that we need Q multiplication, and in C there are P into R elements and each element requires Q multiplication. So total number of multiplication in multiplying two matrices is P into Q into R. Okay, so now let's see a few more things. We saw that okay, it has like exponential number of ways to solve, but that's not what we want an exponential algorithm for it. But let's see, can we solve it using dynamic programming? So we see we have A1, A2, A3. So let's see how many ways we can parenthesize. We can parenthesize it as A1 into A2, A3, or A1, A2 put it together into A3. So this is for size 3. Let's increase the size by 1. So we have A1, A2, A3, A4. What we can do, I can have A1 then A2 bracket A3, A4. We can have A1 then parenthesis A2, A3 together multiplied by A4. So these two are different. Again we can have A1, A2 together, A3, A4 together multiplied. A1 then A2, A3 with A4, this one, and A1, A2 in bracket with A3, this multiplied together, then multiplied with A4. Okay, so these are all possible ways, but what we see, one very important observation, if we see A1, A2, this one calculation and A1, A2 multiplication is repeated in A1, A2, A3, A4 and in its subset A1, A2, A3 here. Okay, so again we see A2, A3 is getting repeated here. So we see there will be a lot of repetitions. A2, A3, then there is A3, A4 here, A3, A4 is here. So we see that it is overlapping subproblem. So we have overlapping subproblem and bingo. So we have got some idea that okay, we can use dynamic programming, and it is also recursive in nature because like solution of bigger problem depends upon solution of smaller sub problems. So what we see now, so let Mij represent the cost of multiplying optimally from I to J matrices. Okay, and what will happen now? So it is basically ai plus 1 till a of j aj. Okay, we want to multiply this together, and let's say that the optimal cost is mi comma j. So now let's say that, okay, we put some one parenthesis, we divide it into two subgroups. I can do it at any position, something like this. So I say let's put a bracket parenthesis at position k. So it will be something like, now I have mi to k, that is the optimal cost, plus mk plus 1 comma j, and plus, so these two, so let's see one example like a1, a2, a3, a4, a5 and a6. So let's say these are the matrices, and what I want is, I want m1 to 6. So let's put one parenthesis somewhere, so I will put at 4. So I multiply like this. So it will be, now k will be equal to what? 4. So m1 comma 4. So this will be the optimal cost of multiplying a1, a2, a3, a4, plus optimal cost of multiplying a5, a6, plus now these two are also matrices of size p0, p4, p6. So we have, this is of size p0, p0 cross p6, and the total cost will be p0, p4, p6. So I write it here. So this is the cost of putting parenthesis and dividing it into two halves. So now I say that, okay, there are only 5 possible ways of doing parenthesis here. One way is a1, I can put a bracket, divide it at this place. Another is that after a2, third one is after a3, fourth one was a4, which we did, one is after a5 also. So there are j minus I places to divide, and the best parenthesis will be the minimum among all. So that's what we write here in the formula, that Mij, so if there is only one matrix, so I is equal to j, so it is Mij will be 0 if I is equal to j, or it is minimum of Mik plus Mk plus 1 comma j plus Pi minus 1 Pk Pj, where I is less than equal to k is less than j. So these are the number of ways to put bracket, j minus I ways, and I find the minimum of all, and that will be the best parenthesis. So now let's take, so what we see is that now we have to fill this Mij's, okay, where I is from 1 to n and j also varies from 1 to n, but what happens is that j should be greater than equal to I. Okay, so it will become something like a upper triangular matrix. Okay, so let's see now with one concrete example. I have a1, a2, a3, a4, a5 and their sizes are given. This is a1 is 4 into 10, a2 10 cross 3, 3 cross 12, 12 cross 20 and 20 cross 7. Okay, so this is the matrix, and now we have j is greater than equal to I, and what we do that we have to find now basically m1 to 5, and to do that we have to do various smaller calculations or sub problems for Mij. Okay, so now I have to fill this upper diagonal. Okay, so upper triangular matrix. So we see that for all m1 comma 1 is just multiplying a1, which is just one matrix, so no multiplications needed. So all m1 comma 1, m2 comma 2, m3 comma 3, 4 comma 4 and 5 comma 5 will be 0. Now m1 comma 2 means what? Multiplying a1 with a2. and we saw the result that if we multiply two matrices, the cost is PQR, where the first one is of size PQ and the second one is of size QR. Okay, so what happens here is that's what we do here. A1 A2 cost will be 4 into 10 into 3, so it is 120. Second one A2 A3, which is represented as M2 comma 3, so that will be 10 into 3 into 12, so it is 360. M3 comma 4 is similarly 3 into 12 into 20, 720, and A4 A5 multiplied is 12 into 20 into 7, so 1680. So now what we will do, so now little tougher calculations. So what we have to do now is M1 comma 3 is what we have to fill. So M1 comma 3 will be minimum of M1 comma 1 plus M2 comma 3 plus P of, so K is here what? 1, so it will be P0, P of, so P0, P2, P0, P1, P3. Okay, and other one will be M1 comma 2, so K is 2 plus M3 comma 3 plus, so it will be P1, so it will be P0, P of 2 and P of 3. Okay, so let's see. So this calculation basically means, so we have something like, so this will be, so M1 comma 2, so this comes out to be 264. Okay, and the other one comes out to be, so this is M1 comma 2, so this is 264, and this is M1 comma 1 plus M2 comma 3, so that comes out to be 840. Okay, so this, so minimum of this is 264. Okay, so similarly, so let's try to calculate, so the other one M2 comma 4. Okay, so we try to calculate now. So we are trying to calculate this diagonal, so we calculated the first one is 264. So similarly, let's try to calculate. So what will happen, let's rub it and try to do it here itself. Okay, so that will be much easier for us to understand. So what we do now is that we try to calculate, for one example, we try to calculate 2 comma 4. Okay, so this will be now minimum of M2 comma 2 plus M3 comma 4 plus, it will be P1, then it will be P2, P4, and other one will be M2 comma 3 plus M4 comma 4 plus P of 1, P3, P4. Okay, so now if we calculate this thing, M2 comma 2 will be 0. Okay, M3 comma 4 will be, we have already calculated this, 3 comma 4 is 720, so this is 720, and this P1, P2, P4, so P1, P2, P4 is what, so P1, P2, P4 is 10 into 3 into 20. 10, 3, 20. So this comes out to be, the first one will be 2, 7. So 1320. And if we calculate the other one, it will be 2760. So again 1320 is the minimum. So we take here this one as 1320. Okay. So similarly, if we calculate the other one, M, what we have to calculate now? M3 comma. So we have to calculate M3 comma 5. The next thing that we have to calculate is M3 comma 5, and if we do similar like this, it will be 1140. Okay. So this is done. So now we will just calculate another one, which is M. So now we have to calculate even bigger calculation, M1 comma 4. Okay. So M1 comma 4 will be now what? So let's see. This will be very interesting. This will be minimum of, so we have to write M1 comma 1 plus M of 2 comma 4 plus P0, P1, P4. Okay. Or it will be M1 comma 2 plus M3 comma 4 plus P0, P2, P4. Or M1 comma 3 plus M4 comma 4 plus P0, P3, P4. So again, now we already know all these values. So I know M1 comma 1, I know M2 comma 4. So M2 comma 4 is known. Okay, it is 1320. So M2 comma 4 is known, 1320 from the table already calculated. M1 comma 1 will be 0 and P0, P1, P4. So let's write that thing here. So P0, P1, P2, P3, P4. So those are given, and those are 4, 10, 3, 12. Okay. So the 4, 10, 3, 12, 20 and P5 is 7. So those are given. So P0, P1, P4, so that comes out to be 40 into 20, so 800. So we calculate all these and we find that, okay, so 1 comma 4, so the values come out to be, so this one is 1224, then 1080, and the last one is, so this is 2120. If you calculate and put the value, so which is the minimum? 1080. So we will put now this value. So this is 1080, and similarly if we calculate the other one, it is 1350. Okay. So now we are almost done. So what is our last step? So we are filling all these diagonal wise, and our last work is what? We have to now calculate the last M1 comma 5. So M1 comma 5 will be minimum of, now what we have to write the dynamic equation, dynamic programming equation, M1 comma 1 plus M1 comma or M2 comma 5 plus P of 0, P of 1, P of 5. Other one is 1 comma 2 plus M3 comma 5 plus P0, P2, P of 5. Next M1 comma 3 plus M4 comma 5 plus P0, P3, P5. Then M1 comma 4, I take the first 4 together, M5 comma 5 plus P0, P4, P5. So So if you again what we have to see is, we know this m2 comma 5 is now also known from the table. M2 comma 5 is known, so we just copy it, and this P0 P1 P5 is known, so all these values are known. So we can directly write 1 comma 4, so this is 1544, this is 2016 1344, and this is 151630. So the minimum is what? 1344. So what we take, so this is 1344. So these many calculations will be taken for the matrix chain. And what we saw was, what we are calculating, just doing this, we are just calculating based on this recursive equation. But what we are doing, that whatever the values we are calculating, now we are using them. So we filled the table here, now we are populating based on the previous values, this diagonal, then this diagonal, then this diagonal, and lastly the final one. Okay, so this was for dynamic programming for matrix chain multiplication, and I hope you understand this. And if you like this video, please subscribe to my YouTube channel. Of course, this was an involved question, but the few things that you have to remember here are only this thing, that A and B, if they are of size P, Q and QR, then the number of matrix multiplication is PQR. And then what you do, so then we wrote one equation that Mij is 0 if I is equal to j, that okay, one matrix there is no multiplication, okay, so 0. Otherwise we can put parenthesis anywhere in the j minus I options, and that's what we are doing here. And then I find the minimum among them all. And why is it easy to find? Because all these diagonal elements are already calculated in our previous iteration. So this was about matrix chain multiplication. Thanks a lot.